All right, I think I gave everybody enough time to join. Welcome to the Nuts and Bolts of Surfer's 3D View webinar. Hi, everyone. My name is Drew Dudley. I'm part of the customer support and account management teams here at Golden Software, and I'll be your presenter for today's webinar. I'm here to give you the lowdown on how to leverage Surfer's 3D View to better display your data and enhance your projects. I will get to these details in just a minute or two. But first, I wanted to cover just a few housekeeping items. After the discussion of each topic today, I'm going to stop for a few minutes to answer any questions that may have came up. You can send your questions over to our webinar host, Jake, via the Q&A button located on the Zoom toolbar at any time during the presentation. Please type in your question. It will be sent over to our webinar host, who will then either answer it or forward it to me to answer. It's important that you use the Q&A function rather than the chat. This will allow our webinar team to ensure that we see all the questions in a timely manner. Again, feel free to send in your questions at any time. If we don't have time to answer them during today's presentation, then we will reply via email once the webinar is complete. We're also recording today. So later this week, we will be posting a recording along with the data that I used in today's presentation. And we'll send each of you a link once it's posted so you can test out the examples yourself. All right, so let's go ahead and get started. 3D data visualization allows you to capture detailed responses from the project stakeholders by showcasing and communicating a more realistic and lively graphical presentation of your data. So we've been spending a lot of time over the past year or so enhancing Surfer's 3D view by adding a number of new features that'll do just that, where it will give your data that depth and that dimension that you need and provides a better understanding of your project for your project stakeholders. And this, of course, is all in 3D. So specifically today, I'm going to be walking everyone through the entire creation and customization process for a 3D view in Surfer, starting with discussing the mapping requirements for launching the 3D view. Then we're going to talk about how to convert 2D base layer objects into 3D vector objects so they can be displayed in the 3D view. We'll talk about launching the 3D view, the various ways you can do that, and also discussing 3D vector objects and how to work with those in the 3D view. We'll also talk about the various properties in the 3D view window, and then finally, I'll show you how to export your model from the 3D view to a 3D PDF so we can share that information easily with stakeholders. Now, I'm not really going to go in this specific order today, as we're going to be looking at the 3D view throughout today's presentation. And as you can see, there's a lot of information that I wanted to touch on today, so let's go ahead and just dive right in. All right, so today I'd like to start out with discussing what Surfer needs or requires to create a 3D mapping project so that it can be viewed in Surfer's 3D view window. We added the 3D view window to Surfer a handful of versions ago, and so some of you might already be familiar with this window. If you remember back, previous versions required a grid-based map in order to launch the 3D view. Now we've changed that in the current version of Surfer, where you can also launch that 3D view window after importing a point data set that contains X, Y, and Z data for all the points in the file, or a vector file that contains 3D shapes or Z level information, or even a grid-based layer, of course. So for this first example, I'm going to start out by importing a grid file and then rendering it as a contour layer. So you can see here on screen, I have a blank plot document open. And this is where I'm going to start this first 3D mapping example. So for this first example, I'm going to start out by importing a grid file that was created from tiles that I downloaded from the ALOS Global Digital Surface Model site, which is really an excellent source if you're looking for elevation data worldwide. The particular grid file that I'm going to be showing you here, I created, again, using Surfer's Grid Mosaic tool by stitching together 21 different TIFF files. And then I downsampled the grid by about 50% because I really didn't need that level of detail. And you'll see that here in just a moment. All right, so in this new plot window, I'm going to create a contour map. First by going up to the ribbon, of course, and clicking Home, New Map, and Contour. I'm going to find my elevation data. As I scroll down, you can see all these different TIFF files that I used here. And select my grid file. I'm going to go ahead and click Open. And now you can see that new contour layer has been created. So just zoom in just a little bit here. I'm going to add some color by filling the contour levels. All right, there you go. That looks a little bit better. And now that the contour layer has been created here in our 2D plot window, let's take a look at how to view this in the 3D view window so we can have that full 3D rotation. So I'm going to go ahead and launch the 3D view window. First thing we need to do is go over to the contents, make sure the map level object or map frame itself is selected. Then we can go to the property window, click on the view tab, and you can see we have the 3D view control with this 3D view button. I can either click here, or I can also go up to the ribbon, click on Map Tools, View, 3D View. All right, and so after giving a surfer a second here to render the surface, you can see the 3D view window appears with a 3D surface and a contour layer, and you can see the contents here of the 3D map we're looking at by looking at the contents window. And so I'm going to rotate this around so you can take a look here. As you can see, again, this is a very, very detailed surface. And really, so much so, it's really hard to tell what's going on here. And namely, that's due to the 3D, or the vertical exaggeration, rather. So I'm going to go ahead and remove some of this vertical exaggeration so that our surface appears more realistic and not so jagged. Okay. All right, to do so, I'm going to make sure that I have environment selected here in the contents window. I'm going to move down to the properties window and click on the general tab, and you can see that we have a vertical exaggeration control. So I'm going to go ahead and just adjust the slider here and lower the vertical exaggeration until I get to a point to where I feel it's more realistic looking. And you know, I probably should have mentioned this. The data that we're looking at here, the surface, straddles the California and southern Nevada border. Okay, and so it is quite a mountainous area. And I think we've got a better looking surface by dropping that exaggeration down a little bit. And I did want to point out, if you want to type in a specific vertical exaggeration value here, you can do so. And you might also notice that this number is a little bit difficult to work with, and that's because I'm using a surface or a grid file rather that is lat long by meters in the Z direction. These numbers get a little bit more user friendly if you do use a map that's consistent in units in all three directions. For example, UTM meters, so to be meters by meters by meters. And we'll take a look at that here in just a moment as well. All right, so again, as I rotate this surface around, you can see that the relief looks a little bit more appropriate and lifelike. And before I move on, I wanted to show everyone some more of the environmental controls. Okay, and so again, with the environmental object selected here in the contents window, again, I'm going to move down to the properties, and let's take a look real quick at the camera controls. Okay, and on the camera tab here in the properties, you can see that we have the camera control position and the target. And I usually don't necessarily change these target or position controls. And you can see that the position moves as we rotate the surface around the X and Y and Z position coordinates. If you're trying to make a consistent export of a static image, you can find the same position and target point by making note of these and entering these to get that consistent look. But probably more importantly is the field of view control. And I'll show you a little trick here. This is going to zoom in or zoom out as we move the slider. Okay. And for some of you that are using a mouse pad instead of a standard mouse, you may find this control a little easier to zoom in than actually using the mouse pad. So do keep that in mind. Okay, nice little trick. And then I'm going to tab over to the lighting tab. And this is where you're going to find the controls for the lighting mode for the model. Okay, and so you can see that that we have a model control, which by default, Surfer uses the smooth lighting model, but we can also change this to none. You can see that removes all of that top-down shadowing effect. And this does provide a nice look for your surfaces, okay? We can also choose a flat lighting mode, okay? And this is gonna be have a little bit different shadowing effect on the geometry. And then you also have some other controls below. I'm gonna flip this back to smooth. Okay. And you can see that we have full control over the lighting position. And as I move that slider around, you can see how those shadows and the lighting react when I change either of these controls. And so this is going to allow you to really get any lighting view on the surface that you're working with. Right below, we also have some ambient color and diffuse color controls. By default, Surfer uses black, but if we did something like switch this to red, right, we get a real interesting effect on the surface. Not that you'd always want to do this, but it is there. Okay, just to let you know. And then right at the bottom, we have a 3D symbol control. This allows the shadows to be shown on the 3D symbols or 3D objects like the polymesh surfaces, which I'll be showing you here shortly. So just make note of this control. If the shadowing doesn't quite look like what you want, you can edit these controls on the lighting tab. All right, and so I wanted to move on now to discuss and show you how to add 2D base layer objects to our map that then will also display in the 3D view window. So I'm going to go ahead and tab back to our map here. And this can be done by using any point data set that again contains X, Y, and most importantly, the Z coordinates. And then it can be viewed in true 3D space. So again, I'm back here in the plot window. I'm going to add some earthquake event data to our map. All right, so first just need to make sure the map's selected. You can see the bounding box here and the map is highlighted in the contents window. That's great. And so I can add our earthquake data by clicking home, add to map, and in the layer dropdown, I'm going to use the base from data layer. This creates a vector layer from our point data file. All right, so I'm going to navigate to the data, select it, and click open. All right, so in doing so, we see the base from XY data dialog. This is going to allow me to set the X and Y data columns. And I really like the flexibility of this control here, maybe more so than you have over the post layer. And since you can see that my coordinates on the map here are lat long, I'm going to change the X and Y here to the lat long coordinates in my data file. Of course, long's always X, and then lat's always Y. All right, so now that I have that set, let's go ahead and add these event locations here to the map. All right, so if I zoom in just a little bit, you should see a series of crosshairs. But with this filled contour map, it is a little bit difficult to see where these locations are. So I'm going to make this a little bit easier to see by adding and applying some symbology to the earthquake data, where I'm going to base the color of our symbols based off the magnitude of each one of these earthquake events. All right, so you can see that I have that vector base layer with earthquake data selected. I'm going to change the symbol. Of course, we can see these a little bit better now. But again, I want to apply some symbology so we can see a little variance here in the event locations. All right, so continuing on with our vector base layer selected here. On the General tab in the Properties, I'm going to click the Edit Symbology button so I can pull up our Symbology dialog. And for our earthquake data, I think I'm going to use unclassed colors. Find my attribute field for magnitude. Okay, there we go. And then I'm also going to change our color map here simply by clicking next to it and picking one that I think is going to look pretty good. Rainbow 3 always does well for me. So I'm going to go ahead to click OK and zoom out just a little bit here. And you can now see all these event locations are now color coded by their magnitude. Now, before we take a look at how these are going to render in the 3D view window, I'm going to add another vector base layer here. I'm going to add another vector base layer here by adding an image from the NAPE server here using our base from server command. Okay. All right, so you see the download online maps dialog. I'm going to expand our NAPE server and actually find the layer that I want. All right, increase the resolution just a little bit here so we get a nice looking image. And then I'm going to go ahead and download this from the USGS server. All right, and you can see we have a new raster-based layer here added to our map stack. I'm going to go ahead and use drag and drop here in the contents window to reorder these, the drawing order. There we go. We can see the aerial image now. And then I'm also going to change the coordinate system here for our data so it's in a more user-friendly system. See here. By changing our map, you can see it's set to WGS 1984. Again, I'm going to change this to a UTM zone 11 projection. There we go. All right, now I'm going to go back and flip over to the 3D view so we can see what our map looks like now. All right. I'm going to zoom in here real quick. All right, you can see that since we made some property changes, the server resets the map, and this is to be expected. And it just means I need to reset our vertical exaggeration again. So again, by selecting the environment variable, go into the general tab here, and I'm going to change our vertical exaggeration. And what you should notice here is that these numbers are a lot more user-friendly. And again, that's because I'm using a map that's consistent in units here. So I'm going to go ahead and just type in 5. We get a more appropriate looking 3D surface again. And then you should also notice that our aerial image that I downloaded from the NAPE server, and also the earthquake event layer, that base from data layer, both of these have been texture mapped and draped over the 3D surface. All right, and so if I scroll up here, you can see that I should notice that there's no data here inside or under rather our surface. And so, as I mentioned just a few minutes ago, this earthquake data can also be displayed in true 3D. And really all I need to do here is to set or assign a Z coordinate for the data. All right, so I'm going to go ahead and show you how to do that right now. Again, just making sure I select the correct layer, the earthquake layer in the contents window. I'm going to move down to the properties and click on this Z coordinate tab. And you can see we only have one control here, and it's a drop down, and I have option to set the Z coordinates to any numeric column that was in my data file. All right, and so you can see, again, since I made that property change, that vertical exaggeration reset, that's okay. I'm just going to go ahead and retype my value in here. And then let me rotate this around so you can see we have all of our earthquake event locations now underneath our 3D surface at that level, at the depth that they occurred, okay, using the Z coordinates from the data file. All right, so now that I have that earthquake data located at the depth that we wanted, more of the properties for this earthquake data layer can be customized by going over to the general tab here in the properties. All right, so for example, I'll zoom out here so we can get a better view here. For example, we can change the sizing method, right? We can change that to fixed, the same as we see it in the plot. Here, let me show you that real quick. Right. And that really brings those up. Or we can have individual control here by using the size slider. So I can bump these up a little bit as well. Go ahead and do that. All right, making these just a little bit easier to see. All right, there we go. And then we can also change things like the symbol color method, right? And so if we wanted these to have that same color as we saw in that I applied the Symbology to, I'm going to go ahead and use the same as plot, right? And you can see now that our event locations here have changed to using that same color scheme or color map that I used when I applied the Symbology. All right. All right, so when I rotate this down, you should notice that the points are still draped here across the top, and we can, or texture mapped, if you will, and we can definitely remove this if we wanted to by changing the properties of the surface. Okay. So I'm going to select the surface here. Again, you can see that in the contents window. And moving down to the properties window, we can see what layers are exactly being texture mapped across our surface. Again, you can see the earthquake data. So if I simply uncheck the box, we can see that those event locations are now not texture mapped. Right? You can still see them underneath. And I can also remove that nape image. Right? And we can see that we're back to that original contour map and 3D surface that was created with that first file that I imported. And we can even do things like turn that surface off and just view the contours. All right. And so it might make a nice effect here for viewing subsurface data that's so close to our surface. Right. All right. So what I'm going to do, a few last things here before I break for some questions. I'm going to show you how to set our symbol here to our 3D sphere. Right, and you can see them, but the shadowing might not quite be exactly as expected. And if you remember, I'm gonna go to the environment, go to our lighting tab, and uncheck this 3D symbol object lighting control. Right, and then we get a much better look here of our event locations. And then finally, it'd be good to know what we're actually looking at. So I'm going to add a color scale. And this is going to show our magnitude range of all these events in the data file. All right, so this is a really good time for me to take a break. So if you have any questions, please, by all means, send those on over to Jake so we can get those answered. All right, and so I have a question about changing to UTM and why did I do that? Good question. Again, if you remember, I always like to work in maps that are consistent in the units, whether that's state plane, feet by feet by feet, or state plane meters by meters, and then also meters in the Z or UTM, the same situation. It just makes more sense, and that's what I'm typically used to using. But also, when we're looking at the vertical exaggeration here, I get much more even and user-friendly values if I use a file that's consistent in all three directions. So, all right, I have one other question. The question is, you mentioned that there was a website that you downloaded the global elevation data from. And what website is that? And I gave Jake a link earlier to share with anybody in case somebody had some questions. So Jake, if you could go ahead and share that with our users today, that'd be great. And again, this is a really good website to get and download. I think it's 30 meter elevation tiles. So thank you, Jake. All right, and so thanks for sending in those questions. We appreciate it. And I'm going to stop again after the second example here to address any other questions that might have come up through this through the second example. So again, if any questions come up, please go ahead and feel free to send those on over to Jake. All right, so for the second example today, I wanted to talk about working with 3D shapes in Surfer. Okay, and to start off with the second example, you can see that I've created a new plot document, and I'm going to import a DXF as a base layer. Okay, I'm going to do so right now, of course, up in the ribbon, home, new map, base. I'm going to navigate to my DXF and click open. Let's view this a little bit closer here. Okay, you can see that I now have a base layer created from that street plan DXF. Right? And since this base layer does have Z coordinates associated with all the polylines here, or all the objects in the base layer. You can see this, of course, by expanding our base layer in the contents window. Clicking on any of the polylines and making the info tab active, and you can see this Z level attribute. Yes, they're all set at 0 here, but since it does have this attribute, the Z level attribute, when we launch the 3D view, it's going to locate at the correct Z level of 0. All right, and again, let's take a look at launching that 3D view. This time I'm going to make sure that my map object or map frame is selected. Moving down to the properties, and then, of course, clicking this 3D view button. All right, as I zoom in here and rotate the map around, it's a little difficult to see if this base layer truly located at the correct Z. I've rotated it so you can see the Z axes, but let's go ahead and add some labels here to the Z axis so we can just verify and ensure that our layers are locating correctly. So I can easily add labels here by selecting the Z axis, right? Going down to the properties, clicking on the labels, and simply checking the show button, right? All right, and we can see that it's going from 200 to negative 200, and at our Z level right here of 0, our base layer located correctly. So that's what we wanted. All right, so let's, again, we're going to be working with some 3D shapes here. So I'm going to tab back to our plot window, okay, to our map. And let's go ahead and draw some polylines on the map that are, they're going to represent a piping network in the area. And then we're going to convert these 2D polygons and polylines to 3D shapes, where we're going to add Z coordinates so they can be displayed in the 3D view at the correct Z level. Okay. And the first thing I need to do here is I'm going to draw these to an empty base layer. So making sure the map is selected, you know, of course, clicking anywhere here, or you can click on the map itself in the contents window. I'm going to go up to the ribbon and add the empty base layer, right? By clicking home, this time add to map, and in our drop-down, layer drop-down, this time I'm going to choose empty base. Okay. Of course, this empty base layer is what I'm going to use to draw the polylines and polygons to. And we can make sure that we have the right ones selected. Surfer is always going to add a new base layers on top of the old ones. But we can also verify that this is the correct empty base layer by clicking this little plus minus sign to see if there are any objects. It's not expanding. That means we have the right one selected. Right, and one thing I need to do also is just to make sure that I actually have the layer clicked, and we see that it is active by this this little arrow, and this indicates that anything that I draw is going to be in the map coordinates of this layer of the base map, and also will ensure that they get drawn to this specific layer. So now that I have my layer selected, I can go up into the ribbon and click Features, Insert, and I'm going to draw a few polylines again that are going to represent some subsurface piping. So, of course, right underneath our street corridor here, I'm going to add another one. And then I'm going to add another one here going the other direction. Okay. I'm going to click Escape on the keyboard just to get out of this drawing tool and get my normal mouse pointer back. There we go. And then before I do anything else, I'm going to make sure that our polylines here are visible. Okay, kind of hard to see with this same color DXF, so I'm going to change them to blue. You can see them, but let's make them a little larger here so we can actually see them. All right, so when I expand our base layer here in the contents window, you can see that, you know, the 3 polylines that I drew. And when I select one of them, and I go down to the info tab, I don't have that Z level attribute. Okay, and so that really is a good indicator that I'm working with a 2D object here. And if I click on the coordinates tab in the properties, I can see that these polylines only have X and Y coordinates. All right. And so we can change these to, easily change these to 3D polylines simply by selecting the polyline and going up to the features tab in the ribbon and clicking change to, and you can see 3D polyline. Okay. So when I go ahead and select 3D polyline, you should notice now that my title's changed, the icon has changed, and probably more importantly, down here on the coordinates tab in the properties, I have this Z coordinate box now where I can enter in the correct Z level. Okay, I'm going to go ahead and do so here for this polyline. And I'm going to do the same for my other two. And I can convert these actually to 3D polylines at the same time. Okay. Get up in the ribbon. And then I need to add in my Z level for both of these. So I'm going to go ahead and do that real quick. So hang tight. Again, for the other polyline, again, this is going to ensure that these 3D polylines do locate at the desired elevation, Z level, or depth, however you want to consider it. Okay, and so now that I've added that the Z level and converted the polylines, I'm going to also draw a polygon. Okay, so making sure my base layer is selected still, I'm going to click Features, Insert Polygon this time. And I'm going to insert a junction box here around our piping network. Again, click that Escape key to get out of my drawing tool. And then I'm going to use the exact same process here to convert this polygon to a 3D polygon. Okay, and so before I do, I'm going to fill it. Matching color here, we can see that junction box. And then let's convert this to a 3D polygon. Again, features, change to. And this time I'm going to select 3D polygon. Same process as I did with the polylines. I'm going to click on the coordinates tab and I'm going to enter the correct Z value for the vertices of my new polygon. Okay. So now that we've entered the Z value for all of our objects and converted them to 3D, let's go ahead and tab back here to the 3D view so you can see where these locate in 3D. Right, and you can see now, and you might notice that the coordinates here on the Z-axis have also updated, which is great. Any changes, again, that we make in the plot window are going to be immediately updated here in the 3D view window, which is great, even including the limits of the axes. Right, and so you can definitely see where that piping network goes as far as our street plan here. And then they did locate here at -10. All right, so I'm going to go back to our map here and add some well locations using the same approach as I did earlier. All right, so again, I'm going to make sure my map is selected, use the home, add to map, and this time in the layer drop down, I'm going to use the base from data command. I'm going to select the well data here. This is a DAT file, click open. Make sure my data columns are set correctly. They are, and click OK. And you can now see some crosshairs. Of course, these are a little hard to see, but the well locations have been added to my map. I'm going to make these just a little bit easier to see. Okay. And then let's go ahead and take a look at what these look like here in our 3D view. Okay. We don't see those yet, but I do see under vector data here in our contents, I see the data file that we just created in that vector base layer. Again, we're going to want to take the Z coordinate and find and assign one here so we can see these in 3D. All right, you can see these well locations, or at least points down, down the borehole. Okay, and everything's fitting together nicely with the coordinates here in the Z range. Okay, and then also top down from consistent coordinates in the X and Y directions. All right, so in addition to 3D polylines and 3D polygons, which we've just touched on, Surfer now also supports 3D polymesh objects. Okay, and so before the webinar, I created some ISO surfaces by grading the same well data that I just added to the map in Voxler, and then exported those as 3D DXF files that contains the 3D polymesh. Right. And so these polymesh objects I'm going to add are going to represent some subsurface LNAPL releases, right? And so let's go ahead and add these so you can see where the contamination data is going to sit in our model. So again, I'm going to tab back to our main plot window and then use the same process to add the 3D DXF or the polymesh objects to our map, by making sure our map is selected, and I can do so by adding some base layers. Okay, so you can see my 3 DXF files here. I can multi-select here just by holding down my Shift key or the Control key, and then I'm going to click Open. And I click No on the limits warning message because I wanted everything to clip to our street map extent here. And then you can see that I have added these polymesh objects. You can see that here, these ISO surfaces. You can, by expanding the layer itself, the base layer, in the contents window and looking at the object here, and you can see those are 3D polymesh. All right, I've got 3 of them. All right, and at this point we don't have a lot of control over what these polymesh objects look like here. But let's go back to our 3D view window and take a look, and they look like just like they did before I exported them from Voxler. Okay. All right, and we can see these pretty easily here in the vector data section of the contents window. And if I turn them off, we can Surfer will drill down and see the different layers of contamination. Of course, this is all in true 3D. All right, there's just a few more things I'm going to show you before we take a break one last time for some questions. And the first thing that I wanted to show you is adding a water level to our model here in the 3D view window, right? And at whatever desired depth that you want. Okay, and so this should per this particular situation should give us a good idea of how the El Napple contamination plume locates in conjunction with, let's say, a groundwater level. Okay, and so again, I can add the water by selecting the environment object in the contents window, moving to the properties window, and clicking on the general tab. And you can see that we have a water control. And I can simply add a level of water by checking our box. You can see it added to the map. And then adding the desired depth here. So again, this could represent the water table if that's the situation you're working in. Okay. And of course, we do have full color control and then some opacity control. I'm going to set this down to about 30 so we can see through that water layer. Right. All right, and one last thing I wanted to show you today is how to export this model to a 3D PDF. So again, you can share that with the project stakeholders. First thing I want to do, I'm going to turn off my background mode, which is set to a skybox, and just set it to a static color. Right, I think white works pretty good here for the 3D PDF. And simply to create the 3D PDF, I can go up to the ribbon and click 3D View, Tools, and then Export 3D. Okay. Now go ahead and click Save. And we do have a lot of options here. I'm not going to dive into these really, but our default settings are probably going to be about your best bet. Okay. So I'm going to go ahead and accept those. And let's take a look at the PDF. All right, I'll change my screen here to the PDF. And really, depending on what PDF reader you're using, it might take just a second for it to open up and render. You can see here that we have just about all the objects that were in the map. And we do have this nice 3D rotation, which this allows you to share your project with the project stakeholders when they don't necessarily have the software installed, or aren't very efficient of it, or you don't want them to make any changes. And so these documents are emailable and easily downloadable. And this is a really good way to share your project. All right. And so let me go back to Surfer here real quick. And here we go. And then I wanted to open it up one last time to address any questions that may have came up from this last section of the presentation. So again, if you have any questions, please feel free to shoot those on over to Jake, and we'll address them. Okay, so the first question is, could the 2D polylines have been drawn with a given Z or a constant Z value? Basically just drawing the 3D polyline at the same time, or at the time of drawing. And we're not quite there yet. That's a really good question. Everything's 2D at this point. Let me flip back over, and then needs to be converted by using our Change To tool. So a great question, and we'll definitely take down your information and add a vote to our suggestion file. Right, and so the next question is, and let me flip back to our 3D view so you can see what the user is asking. All right, so the user wants to know, can I give these polylines and maybe that junction box, that 3D polygon, a thickness, right? And so, for example, they might want it to be, 3 units high or 6 inches around. Or we don't have that control over these 3D shapes yet. I think this is something that we're considering adding. So again, thank you very much for that question. All right, and I have another question. Can I highlight the intersection of the water table with contamination plumes? Right, so if I roll down here, that's really good. That'd be a nice feature request as well. Right now, we can just see where they interact, right? But we could also definitely see, we could definitely add a polygon here. It's at 32.5, so we could definitely add, another polygon layer here if we wanted to, and then set the Z level at that 32 to kind of highlight that intersection. Right? Next question, can the polylines have a gradient? So you can see that each polyline here has, in this case, right, each vertice is listed. These vertices can have different Z levels, right? So we could adjust these so they go from a high-low or low-high, or in this case, we have all three vertices. So the answer to your question is yes. Thank you very much. Okay, Jake, do we have any other questions? Yes, absolutely. So I have another question. How do we export the PDF, the 3D PDF again? All right. So of course, we're in the 3D view. We're just going to go to the 3D view tab, tools, export 3D. When we do so, make sure that save as type is to PDF. We've got the VRML also, vector model we can export. 3D PDF, name the file. And then again, I just accepted the defaults. Okay. By clicking OK. And then the PDF was generated. Okay. Let's see. It looks like I've got another question. Can I show a 3D vector worksheet? Okay, so I'm assuming that you're just asking about this table here, right? So if I exported these objects, I would get that Z value. Okay. All right, looks like I have time for just another 1 or 2 questions. Again, if you have any, please send those on over to Jake. All right, doesn't look like we have any more questions. So that's going to conclude my presentation of the nuts and bolts of Surfer's 3D View webinar. Hopefully everyone found the information that I covered today useful and applicable to their workflows. If you have any questions on what was covered today or anything else Surfer related now that we're concluding the webinar, you can always contact us at surfacesupport@goldensoftware.com. And also, please take a look at our support website at support.goldensoftware.com. And this is where you also find the recording of today's presentation. As always, and on behalf of Golden Software, we thank everyone for their time and have a great afternoon.